Aerodynamics is the branch of science that studies the forces of air and other gases in motion. It is an essential part of aviation, enabling aircraft to stay airborne and maneuver through the air. In this video, we will explore the physics of flight and uncover the aerodynamics of flight. Jump in. Lift is the force that enables aircraft to ascend into the sky and stay airborne. This is achieved by generating an area of low pressure beneath the aircraft's wings, known as the Konda effect. This effect causes a cushion of air to form beneath the branches, providing the necessary lift for the aircraft to stay airborne. The next force is thrust, which is generated by the aircraft's engines. The engine thrust generates the forward momentum needed for the plane to move through the air. Finally, drag is the force that opposes the motion of the aircraft. Drag is caused by the air resistance of the aircraft's body and wings as they move through the air. Pain can be minimized by designing airplanes with smooth surfaces and streamlined shapes. The air pressure differential between the wing's top and bottom generates lift. As air passes over the wing, it moves faster on the top and creates an area of lower pressure, creating a suction force that pulls the branch upwards. This is explained by Bernoulli's principle, which states that an increase in fluid speed results in a decrease in its pressure. This principle allows airplanes to stay airborne. The curved surface of the wing increases airspeed and decreases stress, creating a lift for the aircraft to remain airborne. The physics of lift can be seen in different aircraft types, such as gliders, helicopters, and airplanes. Gliders use the ride to stay airborne by gliding through the air, taking advantage of the charge generated by their wings. Helicopters generate lift by spinning rotors that create an area of low pressure beneath the blades. Airplanes use both charges from the wing and thrust from the engine to stay airborne and move forward. Are you curious to know about the physics behind the Bernoulli principle? Let me tell you. The Bernoulli principle explains how lift is generated, stating that an increase in fluid speed decreases pressure. This is due to the low pressure area created by the increased airspeed. This principle can be demonstrated with a simple experiment, such as blowing air over a piece of paper on a water tube, which will suck it into the box. Aircraft wings are designed to utilize the Bernoulli principle to generate lift by creating a pressure difference as air passes over their curved surfaces. The shape of the wings, such as a curved surface and leading edge, helps to increase airspeed, creating a low-pressure area beneath the wing and generating lift. The angle of attack is the angle at which the wings are angled relative to the airflow. It determines the amount of lift generated by the wings. If the slope is too steep, the aircraft will stall, resulting in a loss of charge, while a too shallow angle will not generate enough bang for the plane to stay airborne. The rise of attack is adjusted by changing the flaps on the wings to optimize the ride and ensure that the aircraft generates enough lift to stay airborne. Turbulence is an essential factor to consider when studying aerodynamics. Turbulence occurs when the air becomes turbulent, resulting in irregular airflow patterns. This can result in a loss of lift and an increase in drag, which can be dangerous for aircraft. To reduce the risk of turbulence, aircraft are designed with smooth surfaces and streamlined shapes, which help to reduce drag and increase efficiency. Additionally, pilots can use specific techniques to avoid turbulent air, such as flying at higher altitudes or avoiding areas of turbulent air. Aerodynamics is a fascinating and complex field of science studying the forces of air and other gases in motion. It is an integral part of aviation, enabling aircraft to stay airborne and easily maneuver through the air. In this article, we explored the physics of flight and uncovered the excellent aerodynamics of flight. We discovered that the differential generates lift in air pressure between the top and bottom of the wing, and that Bernoulli's principle can explain the physics of charge. We also explored how aircraft generate lift, angle of attack, airfoil, and wing design, and the role of turbulence in aerodynamics. Aerodynamics is a fascinating field of science that enables aircraft to stay airborne and easily maneuver through the air. With a better understanding of the complex physics of flight, we can appreciate the excellent aerodynamics of flight and soar to new heights. Thanks for watching our video on the physics of flight, how planes stay in the air. We hope you found it informative and exciting. If you did, Please hit the like button and consider subscribing to our channel for more science and technology videos like this one. We also love to hear from you, so don't hesitate to comment with your thoughts or any questions. We'll make sure to respond as soon as we can. Thank you again for watching infoTube USA, and we'll see you in the following video. Don't forget to turn on notifications so you never miss an update from us. Remember, science is all around us. Let's explore it together.